I welcome you all to the seminar. I'm very excited to talk on this futuristic topic, and I'm sure it's going to be very interesting. So during the global lockdown and in the lockdown period of 2020 and 2021 right now, so you have seen the photos of clear sky, happy birds, wildlife, the animals were onto the roads. Wherever these all photos were really filled up our internet during global lockdown. So we just saw a small pause on polluting human activities. So the outcome was renewed focus. So do you know that? So many countries like US, China, Europe, India is onto the mission of climate change and want to reduce this pollution due to the vehicles. So the European Union pledged to go for carbon neutral by 2050. In the same way, China made a similar pledge to go for the carbon neutral by 2060. Joe Biden, president of US, has made an addressing on climate change in the top priority of his administration. So in India also, we saw some really progressive policies which have been into the scheme, like on FAME 1 and FAME 2 scheme are in order to promote electric vehicle technology. So entire world is looking forward to this technology, and it has been an year of electric. So electric mobility is finally consumer facing. And Tesla made that happen, I feel that. And this is a sign of maturing industry where consumers now able to participate actively in economy, right? And whereas as an engineer, we need to understand this technology very purely. So why? Because if some person comes to you and talk about electric vehicle, like basically if you go on ask the person what is electric vehicle, they'll definitely say it's a vehicle which we need to charge from 0 to 100% and it gives certain range. Everyone knows about it. So, but as an engineer, what we should have to know about electric vehicle. So this is very important, and this is going to be the future. In the second slide itself, I'm sure that I will declare here and that electric vehicles are going to the future, and you will notice it in the last slide. So it is very important for all the engineers with all the respective departments to understand this technology, and this is what it is going to be in the future.
Very good afternoon to one and all once again. My name is Vitesh Kataukar, batch number 24, Division B. Today's seminar topic I am going to talk on is electric vehicle technology and its future.
So moving on to the further slides. So let us have a look with all the contents which have been presentation and seminar today. So we will have a look with the history. Well, electric vehicle have really good and interesting history. We will have a look at that, how the evolution happened until today from the first vehicle which was developed and innovated till now. What's the technology? A lot of differences happening. Evolution is really great and very interesting. So why so much interest in electric vehicles? If you see in today's automotive company, each and every company, you take any company, you take Tata, you take Mahindra, TVS, Bajaj, each and every company has their own electric vehicle right now with them. Not even this, even the companies of manufactured phones, smartphones, these companies are also getting into this electric vehicle market. Like as in Apple have launched their prototype of their electric vehicle. So everyone wants to go to that. So we will have a look with why we are interested in perspective of Indian conditions and why we require and why we need to shift to electric vehicle. This is what we are going to look at this topic. And next, we will slowly go into technical part where we will have a look at types of electric vehicles. Coming to next is introduction to each subsystem. What each subsystem is contributing to electric vehicle. So this is what we are going to have a look at. Coming to next, very important, that is design of battery pack. If you understand the design of battery pack and what each respective department is contributing to electric vehicle, then I suppose you will get to know 50-60% of all electric vehicle design. So it's a very important topic, that is design of battery packs. We will have a look at that. Then lastly, we will go on to what are the futuristic technologies, what will be in the future, and future of electric vehicles. Now coming to the history. So it is very interesting to know that the first EV was built in 1834, which is about 150 years back from now. So it was built on non-rechargeable battery that was available at that time. So basically, use and throw batteries type of technology was there in the first electric vehicle. So after the innovation of lead acid batteries, rechargeable battery EVs was possible, and that was built in 1874 by David Siemens. So with this development, it was possible to develop a commercial product And by 1886, all these developments led to propulsion of electric vehicles. So then slowly development happened. After 12 years, the first electric trolley system was built by Frank and in 1889. So there was slowly development was happening in electric vehicles. Now, if you see this data that in 1900, among 4,200 automobiles that were sold in USA, and 38% were electric vehicles, 22% were ICE engines, and 40% were steam powered. So basically, slowly EV was disappearing from that time in 1900. Steam power was high and ICE engine and slowly was moving on higher and higher. So, but unfortunately, EV started disappearing by 1930s. There was two development which led to happening this or falling down the EVs. The first development was Ford company at that time has gone for a mass production of Ford Model T. So in 1925, I had and was able to reduce the price of it. So the ICE engine vehicles, the Ford company had reduced the price of that vehicle. So due to this, electric vehicles became most costlier. So slowly it's was going down. And second development which had happened, which EVs disappeared, the ICE engine that at that time unable to start on its own and need to manual cranking. And so at that time, electric starter development was happened. So this is the second point which EV disappeared at that time, and ICE engine vehicles were popular. So I've divided this history part in phase 1, phase 2, and phase 3. So whatever I've talked till now is phase 1. And in phase 2, what happened is, so after a gap of around 40 years, so again there was an evolution of electric vehicles. So there were few developments at that time which led to EV come up again. That is, first was, there was oil shortage in Arabian countries. And global countries were looking at the possible alternatives for energy sources. And then secondly, where EV came up again by 1950s onwards, a lot of cities have seen worse kind of smoke, pollution. And this has pushed the government to bring strict rules and regulation which can enable the government to take decisions. So in the development of electric vehicle technology, and make it feasible for the commercial developments of electric vehicles. From then, slowly again electric vehicles came again. So many automakers in US, Japan, Europe started developing electric vehicles. So you can see in US, GM and Ford was there, were developing electric vehicles, and Japan was having a Toyota, Nissan, Honda, Suzuki was there. In Europe, BMW, Mercedes-Benz, Audi, Volvo. So these are the companies where slowly started developing, innovating electric vehicle technology. So coming to the phase 3, which is the current scenario. In the current scenario, EVs are extremely popular, and you can see actually see the vehicles on roads, how they are performing well. So EVs are extremely popular, and they are able to compete with conventional ICE engine. So in terms of performance, and these are the famous Tesla models, which everyone are fan of this vehicle, which made that happen, where consumers are facing electric vehicles. Tesla Roadster was the first in 2007, which Tesla electric vehicles were launched, and then Tesla Model came in 2012. Tesla Model S and Model X came then in 2015. Model 3 came in 2017, and also I think around 4-5 electric vehicles they have launched, the Tesla models, and one is Cybertruck. Yes, it is a Cybertruck, the fifth vehicle. And then in the recent, you can see this is a company which I've mentioned. There are many companies which are there into the market. One is Nissan Leaf, BMW i3, Tata Nexon. You can see these vehicles on Indian roads as well. Tata Nexon is there, Honda Icona is there, and Mahindra e-Trio, 450, Revolt RV400, Bajaj Tiger. These are two-wheelers which are coming to markets. So this is the current scenario which is right now in electric vehicle technology. So moving on to why so much interest in electric vehicles? So why we want to go for and shift for electric vehicles?
So if you Google it out, world's most polluted city. So out of it, if you have a look with this, which I've Googled it right now with this, I've taken a screenshot. So from number 2 to number 40, all of these are Indian cities. Very disappointing. So in COVID times, those who have stepped out and seen and felt a clean air after years. So basically what had happened is the petrol vehicles stopped playing and the diesel vehicles were not there. And suddenly we see the cleanliness of air. So the vehicles, the petrol and diesel vehicles, do contribute very significantly to the poor air quality. So I've mentioned some of the fun facts over here, which I was circulated on internet on those days. Because of less air pollution, I can see Mars from my village. View from my balcony due to less air pollution. This is just for the fun fact which I've mentioned here. And these are the real fact which I've seen in the lockdown period last year. Delhi pollution free, you can see the difference here that happened. Ozone layer was fixed thanks to the lockdown. And this is the real fact. The Himalayan ranges are visible from 230 kilometers away due to less air pollution in lockdown. This is what amazing things were happening in lockdown period. We've just felt so many things are happening. Birds were really free for them, very fresh air, cleanliness of air, open sky, blue sky was visible completely. There's a lot of things that happen. So that is a part of the reason why everybody is saying, can we get electric vehicles? Can we at least eliminate this source of pollution? And this is what we have seen in the lockdown. Complete vehicle was shut down and we have seen this difference. So look at the changes which are happening. So that is why every country is moving forward, promoting electric vehicles, and we need to also support in order to shift to electric vehicles. The second reason is here why we need to shift to electric vehicles. Coming to the next, that is crude oil imports. So we have very, very large and we imports of crude oil, and we of course want to get rid of it. Around 90% of oil is imported from outside. Only 10%, I guess, in the form of India, we take out the crude oil from India. So once we move to electricity can be produced in India through renewable energy, there is no doubt, and we will suddenly get rid of this. So this is very important motivation. Well, government is what having a motivation of this. If this is getting reduced, then definitely our economy will get fixed. Petroleum consumption, you can see a petroleum consumption up from 32.5 million tons in 1981 to 18.4 million tons in 2015, and it is higher even today. And coming to the next point, why we need to shift to electric vehicles. So electric vehicles is 4 times more energy efficient as ICE engines. So other motivation is purely in energy efficiency terms. So this is actually come to me also very surprising that electric vehicles is 4 times more energy efficient as compared to petrol engines or diesel engines. So this is something what internal combustion basically has. 22%, 23%, 24%. Whereas in electric vehicles, it starts from 90% of efficiency, 92%, 95% of efficiency. We always studies in mechanical engineer, right? We always try to improve efficiency. We always calculate for efficiencies. Well, world is moving forward for more and more efficiency. So this is where engineers should get motivation from in order to shift to electric. Next comes has 50 times less moving parts. It is correct. So petrol and diesel vehicles has very large number of moving parts. Whereas once you come to electric, it has actually very few moving parts, and therefore almost 50% less number of moving parts. Now moving on to a little bit in technical part, we will have a look at all the types of electric vehicles. I've just noted it here and we will go in detail in the further slides. First one is battery electric vehicle, only electric, hybrid electric vehicle, plug-in hybrid electric vehicle, fuel cell electric vehicle. These are some type. And now we will go with detailing in all the terms. The first one is battery electric vehicles. So as you can see here, this is the open vehicle of Tesla vehicle. A battery electric vehicle is a pure vehicle, a type of vehicle that exclusively uses chemical energy stored in the rechargeable batteries with no secondary source of propulsion. So it only uses a battery pack and a motor to drive. We need to charge it to the grid from 0 to 100%, and the only energy it uses is battery pack. That's all. As simple as that. Coming to the next type of vehicle is hybrid electric vehicle. So hybrid electric vehicle is a type of vehicle that combines a conventional internal combustion engine system with electric propulsion system. So as you can see in this vehicle, we have a battery pack as well as a fuel tank. So I can fill the fuel tank and I can run on engine as well as with a battery pack. So whenever there is a need and assistance for engine with the battery, it's going to assist a vehicle by help of battery pack. So both the power sources are being used here. So these are some classifications of hybrid electric vehicle. We will not go in detail with this. We will just have a look at what are the classifications of hybrid electric vehicles. So one is series hybrid, parallel hybrid, series parallel hybrid, plug-in hybrid, mild hybrid, and micro hybrid. These are the classifications of hybrid electric vehicle. Now coming on to the next type of technology, that is plug-in hybrid electric vehicle. This is very interesting, and this is what we currently are working on two-wheelers. So plug-in hybrid electric vehicle is a hybrid electric vehicle whose battery can be recharged by plugging a charging cable into an external electric power source, in addition to internally by its onboard internal combustion engine generator. So basically I can use this vehicle as completely petrol as well as completely electric. So it gives an option for charging through the grid also. So I can charge the electric vehicle from 0 to 100% and use it for fully electric battery pack, and I can refill the gas and I can use it as a petrol as well. And during the travel, it also going to interact with both of them. Whenever there is a regeneration for the battery charging, it is going to assist and give the power to the motor, and it's going to recharge the battery. These are all things are happening. Next comes is fuel cell electric vehicle. So fuel cell electric vehicle basically uses a hydrogen tank. So this is also, let's consider this is a battery electric vehicle. The only change is we have hydrogen tank and a fuel cell stack. So this hydrogen cylinder is hydrogen gas is liquid is being supplied to this fuel stack. So this fuel cell stack will going to produce an electricity. So this electricity again it is going to be used for charging the battery and giving the supply to the battery. So then after the process of how it is going to supply to the motor and all this remains the same as a battery electric vehicles. The only change is we are going to refill the hydrogen liquid in this vehicle. We're not going to have a petrol slot, or we're not going to have a petrol charging slot. We are going to have a hydrogen tank. We are going to refill the hydrogen here. So this is where under the vehicle is under the development and research, and maybe after some few years, or maybe after 5, 8 years, 10 years, it will take in order to come onto the roads. We have seen some of the companies that actually launched a prototype of fuel cell electric vehicles, and that is interesting that it is going to and it is working really fine at that company. Now we will have a look with the introduction to each subsystem. So there are certain major important components in electric vehicle which we should have to be understood about, and what these components are contributing to electric vehicle, we will have a look with that now. So as you can see here, these are all the components of placements in electric vehicle. So there is a traction battery, we have a charging port, we have a transmission system, we have onboard charger, battery, auxiliaries, thermal system for cooling, DC-DC converter, power electronics controller, electric traction motor we have. So we have different assemblies and placements on every electric vehicles. Whereas if you look at the battery pack here, this is placed at the bottom of the electric vehicle car, placed at the bottom of the car. So this gives additional advantage to an electric vehicles. So we always study of CG, right? We always study of center of gravity. So it gives additional advantage to electric vehicles. So while taking a turns and vehicles start flipping upside down. So the chances of flipping get reduced due to the battery pack placements here. Because higher weight is there, very low CG is there. That is why the chances of flipping while turning and all, accidents and all will reduce by this technology and the placements of battery pack. Coming to the next is we will now look at the each and every components of electric vehicles. So the first is electric motor, very important. High performance electric motor is used to propulsions. Next is motor controller. So suppose if I'm using induction motor here in my electric vehicle, I should be having an individual motor controller, respective controller for that. So that is programmed in such a way that it should have to supply required voltage and supply to the motor. If I'm using a BLDC motor, again the respective control will be there for that motor. Again the separate program and algorithms will be there for that motor. Next is transmission system. So basically in electric vehicles, there is no lot of transmission or moving parts, as we've discussed, less moving parts, right? 50 times less moving part in electric vehicles. Whereas here in transmission, it only uses around 1:2 or 2:2 ratio. That's all. Gear ratio we have, right? We are using only 1:2 or 2:2 ratios of gear in electric vehicles. Why? Because motors actually having really good torque, initial torque at the starting. So we do not require a gear ratio. The motor itself doing its work very fine. Next is very important, a battery pack and BMS. BMS is basically a battery management system. We will have a look with in detail in the further slides.
Next type of components in electric vehicles are DC-DC converters. So in my project here, I'm using 72 volts battery pack. So for 72 volt battery pack, in order to supply the voltage to auxiliaries for indicators, for headlights, so I need to reduce that voltage. I cannot directly give 72 volts to them. So DC-DC converter is basically going to reduce the voltage and bring on to the required voltage. In my example, that is 12 volts. Then comes IoT and telematics. So as we all have seen that sitting out here in my homes, just by clicking some buttons on my phone, I can actually see what is the percentage of the battery. I just want to switch on the AC, then I can just by one click I can switch on the AC inside a car. If I am in a coffee shop and if I'm lazy being for going on till the car, I can call the car just by clicking one button in my phone. That's really amazing things are happening in this technology. This is one among the part in electric vehicle, that is IoT, Internet of Things and telematics. Next comes a master controller, which has been used for vehicle management and safety purpose. And next is charging port. A charging port is not actually a component of electric vehicle, but yes, an onboard charger, we can call it as an component of electric vehicle, because onboard charger has a charging system inside the vehicle itself, whereas an external charger, all the charging system will be outside the vehicle. Moving on to the next slides, that is battery pack design. We will focus more on this battery pack designing and BMS because it's very, very important to understand. So the first thing we will notice how these battery packs are built. So there are certain cells we have everyone have seen this kind of cells, right? We have seen in the laptop batteries. There is, we have seen in some electronics devices. These are the same kind of cells that have been used in electric vehicles. So these electric vehicles are connected in such a way that it should give a required capacity of voltage and current to the required application. So these are connected in series and parallel configurations. So, and this series and configuration makes modules. So as you can see in this picture, we have one module which is made up of these cells connected in series and parallel configuration. Again, in further, these modules are connected again in series and parallel configuration. So this connection of modules makes a complete battery pack. So this is not the only thing which is happening in battery pack. There are a lot of things are there in battery pack, where I can say this is a complete mechatronic system, where we have sensors. We need to sense the temperature of batteries. We need to sense the current and voltage of the battery. We need to have really good thermal system in them. So it's completely a mechatronic system we can call as a battery pack. This is the battery pack which I've taken of one vehicle. You can see here actual battery pack of electric cars. Next come lithium battery chemistry. These are some battery chemistries which I've mentioned in this picture. As you can see, NMC batteries, NCA batteries, LFP batteries, NMC batteries, such as in most of the vehicles right now are using NMCs and NCA batteries. As you can see here, in NCA batteries being used by Tesla vehicles right here. And in our project, we are using LFP batteries, which is lithium ferrous phosphate chemistry of battery packs. And each chemistry have their own advantages and disadvantages. According to the application, according to your budget, we need to select this technology and chemistries of battery packs. Next, we will have a look at battery price, how it is reducing. So we've taken this data from one of the source, where, as you can see here, the energy density, which is watt hour per kg. So in 2011, it was 80. For 80 watt hour per kg, the price was $800 per kilowatt hour. Whereas in 2015, 140, again, it has been reduced to 275. Look at the difference here. Again, in 2020, for 310 watt hour per kg, the cell price per kilowatt is $110, which has been reduced from $800 to $110 with higher energy density. So isn't it amazing? So in the future, definitely it's going to reduce again. So now we will move on to the battery pack designing. The first, in battery pack designing, there is each and individual departments have their own contribution in order to design this kind of a technology in batteries. So the first is electrical design. The first point is capacity, voltage, and current. So it deals with the electrical design deals with capacity, voltage, and current. So suppose I need to build a 2 kilowatt of battery pack. What number of cells are required for that? What is the series and parallel configuration I need to do in order to achieve that much of capacity of battery? So these are all things which is done by electrical engineers. And next is high voltage isolation. So it is very important. So the DC voltage is safe up to 60 to 100 voltage, I guess. Yes, 60 to 100 voltage. It is safe for human beings. So beyond that, it will definitely going to give you the shocks. So if there is any leakage, if any high voltage touching to the vehicle, then it could be a problem. So therefore, the design should be in such a way that it should isolate each and every terminals of electric. Next comes the third point is short circuit scenarios. A short circuit is basically a connection of positive and negative terminal. So we should have to take care of that as well. The short circuit scenario should not be there. Fourth point, efficient power delivery. So this is also very important, where electrical engineers have to take care of it. Where if you're using higher resistance wire and length should be higher, so it is going to reduce the efficiency of electrons traveling through it. So if I take a long elastic wires and connect to the battery pack, so instead of analyzing or where I can utilize lower resistance wire, so if I'm using a higher resistive wires, definitely the efficiency of the power delivery will reduce. So electrical engineers have to take care of this as well. Moving on to the next design, that is thermal design. So what is thermal design do? It improves the pack efficiency. So if you maintain the temperature, particularly into the battery packs, the life of the battery get increased. So if the vehicle has, if you go onto the Ladakh side and Kashmir side, temperature is around in minus. Again, if you come to a little bit down in the Rajasthan and all, the temperature is very high. So the thermal design is very important in order to achieve higher efficiency and improve the life of the battery. So in electronics, it is a known fact that every 10-degree increase in temperature would bring the life to half. So very important task, very important design, where mechanical engineers are familiar with this thermal design. Coming on to the next part, that is mechanical design. So if the battery pack is broken, so as shown in this picture, this vehicle has gone to an accident. So if the battery pack is broken at that time, then what will happen? We don't have any control there. It could be a muddy area, it could be a waterlogged area. People will come closer to it, and people take pictures of it. A lot of things will happen. So because of the impact on the cell, it may lead to the fire. So it may go on to the fire. And it is very harmful for the humans, and if suppose someone comes near to it, it's going to be very dangerous. So as it will turn out to the bomb itself. So here is the safest tip which I'm giving now. That is, when you see an electric vehicle which have gone to an accident or catch the fire, do not ever throw a water onto it. So if you go on supplying water for an accident vehicle, it will definitely turn out to, and again it will the fire will happen because of the chemistry which is present in that battery pack. Always try to go for something which is not a moisturous. Like sand is there, mud is there. You can have a look with it. You can reduce that actions. You can take the action by putting the sand onto it or by putting mud onto it, but never ever put a water on an accident electric vehicle. It will definitely turn out to a bomb completely. It will burst completely. And one of the example that happened with Tesla cars, one of the person had thrown a water on it, and it has turned out to a very big blast. So we need to take care of it, and this is for the information which I'm giving right now. This is for the information which I wanted to give. So the next is cost. So we should select the material which will reduce the cost of the vehicle. With that also, we should have to give a required strength for that vehicle. Next is productivity. What do you mean by productivity? Is basically we can assemble or disassemble the battery pack for the services and recycling it quickly. So this is basically what productivity is in electric vehicles. Next is reliability. So it should not fail without giving a warning while having certain kind of things. So the next design comes is battery management system, BMS. So BMS is basically what it does is it is maintaining the cells and pack operation limits. It prevents the safety concern events. If there is a high voltage, frequency voltage is coming up input from them, it is going to give the warning and get into the safe mode.
controlling of thermal system, communication and diagnosis. It should also communicate with the vehicles components and as well as like external components like charging ports. It should have a communication with them. Moving on to the electric motor, so the first is DC series motor, which widely been used in back in 1990s, but now it has been not used. Next is brushless DC motor, a BLDC, which is used in many of the electric scooters and bikes. Since we are using the BLDC motor itself in our project, as you can see, we have posted a picture of this BLDC motor of our project. Next is permanent magnet synchronous motor. This is also widely used motor in cars. As in Toyota Prius is using this PMSM motor, three-phase induction motor. This is the motor which is currently used in Tesla electric vehicles. Tesla vehicles have really unique design of motors. You will never get an induction motor as the Tesla vehicle has. It has really unique design of electric motors. I do not have recently to show the picture of what the changes and what is the uniqueness of that motor, but yes, Tesla actually uses three-phase induction motors, and right now currently the motors which have been changed. Now we will have a look with what are the common parts between electric vehicles and IC engine vehicles. So electric vehicles, basically what you have been looked at till now is all what are the changes which is going to be happening. So instead of a fuel tank, we have a battery pack there. So there are certain changes, but there are some common parts also where there is no difference between electric vehicles and IC engine. One is body frame and doors and power windows, wheels, suspension system, safety system. These are all will be same. But whereas in safety system, there is an additionally in electric vehicle that a battery will require an extra safety. So this is addition for electric vehicle will be added. Next is power steering system will remain same, power braking system, wipers and fluid pumps, mirrors, interiors. So these all will be remaining same as IC engine vehicles which we are using right now. Now let us have a look with the future of electric vehicles. Very interesting. So the first is electric vehicle on road by 2030. So Niti Aayog and Government of India, electric vehicle target says 70% of all commercial cars, 30% of private cars, 40% of buses and 80% of two-wheelers and three-wheeler sales in 2030 would be electric. But yes, I do not, I guess this would be extended. It will not be at 2030 because of the pandemic which has happened right now, which has impacted very badly in this field also. In electric vehicle field, a lot of startups which are having a lot of startups had been happening in electric vehicles. They have currently not doing well due to the pandemic. Also, some big brand companies are also little bit getting lower due to this pandemic. So I guess by around 2035, 2040, definitely this all data will be true. Coming to the next point, that is number 2, that is power back to the grid. So when electric vehicles are not in use, we actually can transfer that charges to the grid. So as we do in charging, we take the electricity from the grid and charge the battery pack. In the same way, I can take the electricity of the battery pack and go to the grid. So this can be used for further, like in offices, in homes, and can be used anywhere. So this will be the very effective technology, and that will be definitely be in the future. That can be in the future. That is power back to the grid. Next, third point is more effective, efficient and lighter weight batteries. More efficient and lighter batteries. So we will have a look with detailedly what are the technologies and what are the future batteries. Like as I mentioned here, lithium-ion batteries, lithium metal batteries, solid-state batteries. These are all the technologies of batteries. Moving on to the fourth point is FCEVs. There is also research being done on fuel cell electric vehicles, and maybe we can see we can see the fuel cell electric vehicles on road maybe after 5 years or 10 years it may take. But recently fuel cell electric vehicles is under development, and I guess one of the company has built this fuel cell electric vehicles, and it is actually working really fine. So maybe in the future we can see fuel cell electric vehicle as well. Next, that is fifth point, is battery swapping technology. So battery swapping technology is basically we are swapping the battery pack. So when you use the battery packs, when it reaches to 0% of SOC for battery pack, you come to the station, you swap the battery and put the 100% fully charged battery into your vehicle and just go on.
and it will just take around 5 minutes almost. And when you go to buy an electric vehicle, you actually buy without a battery pack. So when you buy without a battery pack, definitely the vehicle price is going to reduce up to around 40% to 50%, because battery pack are actually very costly. In my project itself, we have invested around 30,000 rupees to the battery pack, and around 25,000 only for the electric components. So around 50% above I've invested in battery pack only. So when you purchase an electric vehicle without a battery pack, it is going to be very cheap for you, and you will be having a contract with this kind of a companies like Sun Mobility. So when you have a contract with them, you can use their battery by giving them the rent for that battery packs. So you can swap whenever you required according to your travel what you have been. So particularly you will have a complete network of battery swapping technology, and maybe India will definitely have this battery technology, though it is having right now in metro cities. If we go in Bengaluru, this is a picture of taken in Bengaluru, that he is swapping the battery pack for his electric rickshaw. So this can be and will be the future in electric vehicles, that is battery swapping technology. So there is a company at Sun Mobility based in Bangalore has one e-rickshaws and two-wheelers will have swapping stations in. So there is really a complete network of swapping stations. So moving on to the further future part is batteries in future. So this is very important. If there is a future in battery packs, then there will be the future in electric vehicles, right? So we will have a look with the battery pack in future. So as I mentioned here, this table is actually taken out from Battery University, where we can see in first one is lithium air and lithium metal is there, sodium solid state lithium, lithium sulfur is there, sodium iron. These are the technologies are under development, which is happening right now. And one of them are very, very interesting. One is lithium iron, lithium metal batteries. So as you can see here in the specific energy, 13 kilowatt hour per kg. Theoretically, they are saying that lithium air batteries has specific energy of 13 kilowatt hour per kg. So this will be the game changer if this comes in future. Lithium metal air batteries and lithium aluminum air batteries gives around 1000 and above kilometers only in a single charge. You might have seen some news, right? The vehicle is giving around 1000 kilometers in a single charge. What they're using this kind of technologies. So in future, if this technology really work, then definitely electric vehicles will be the future. We might see each and every household will have electric vehicle with us. And you can see this kind of, if this kind of a, who do not like if I charge it once, can travel out for 1000 kilometers, definitely it will be very impressive for the customers. And if this comes, then definitely electric vehicles will be the future for sure. So these are some references which I've taken out from, which had really helped me a lot in understanding the concepts, and also would like to thank to all these professors and all these papers in order to providing a free source of knowledge, which is giving a lot of knowledge concepts. Yeah, that's all from my side, sir. Thank you so much for your attention. If there are any questions, then I will try to answer those. Thank you so much. Thank you one and all.